Hello. We continue building up your geometrical intuition around systems of linear equations, and now we have just one case left, one which can be illustrated geometrically, and then I will make a kind of conclusion in the next video. So in this video we are looking at possible solution sets of 2×3 systems of linear equations, and I will also tell you what it means that a system is underdetermined. So in the previous video we analyzed 3×3 systems of equations, and this means that we analyzed systems of 3 equations with 3 unknown, which we usually called x, y, and z, and each such equation represents a plane in the space. And graphically we had this kind of configurations, which represented systems with 0 solutions, 1 solution, 1 parameter solution, and 2 parameter solutions. And now we have just 2×3 systems, which look like this, and each equation represents a plane in the space, but now we have just 2 planes. So now it's quite easy. We just have 3 possibilities. Either are our planes parallel to each other, or they intersect along a straight line, or they are actually the same plane. And the first case gives us an inconsistent system of equations with no solutions because, well, parallel planes do not intersect. In the second case we have a 1 parameter solution, so all the points on the line give 1 solution, and so it's like infinitely many solutions. Or we have 2 parameter solutions. Each point on the plane gives 1 solution. And very important observation, 2 planes can never intersect in exactly 1 point. So it is simply geometrically impossible. They cannot intersect in 2 points or 3, so it's just no intersection at all, intersection along a straight line, or just 2 planes which are the same plane. And the last slide with some terminology. A system of equations is called underdetermined if the number of equations is less than the number of unknowns. So if the system looks like this, for example. And generally an m×n system, so it means a system of m equations with n unknowns, is underdetermined if m is less than n. So if the number of equations is less than the number of unknowns. And why is such a system called underdetermined? Well, because it has too few equations in order to determine a unique solution to the system. So the system is not representing a unique solution. It will either have no solutions at all, so we will call it then inconsistent, or it will have infinitely many solutions. But a situation where such a system represents a unique solution is impossible. So underdetermined is because it has too few equations in order to determine a unique solution. And it was the last slide of this lecture. Thank you for watching. Bye bye.